All right. Hello and welcome. Today we are going to, once I see that the chat is there, right? Hello. We are going to start adding the, creating the tagged unions for C3. And that goes through a few stages. One, we need to, do the, and to, well, that's the parsing for, just the union. Right? And then we have semantic analysis of the union. And then we had to add the supporting syntax and also supporting and then runtime checks and compilation. So there are a bunch of things to be done. And I don't know how much I'll do this time here, but I think I'll get through at least the first one. So first off, let me hear from you in the chat. Does it sound okay? Do you hear what I'm saying? So type something so that I can know for sure that you're actually hearing what I'm saying. All right, good. Then without further ado, let's jump into, we have some runs that I did for just today. Okay, and I'll turn on the, you'll actually maybe see my picture in the corner there. Do you see me? Is that like, hang on. I kind of have too many windows right now. So yeah, I'm kind of there, right? Good. Okay, so then we go. Then here we go. We are going first. Let me show you what we will want to parse. So we're going to parse a struct foo, and that one has something we call an A in this case, and that's going to be our tag. And we're going to have A as our tag in this case. And then we have, we can double B and avoid pointer, right? So these are two. This is the tag, and basically this is how it's going to look. We could have a name here as well, but we want to start by just parsing this. So we are not going to go into, like, you could think that you want to do this as parse union. Let me see. Parse struct union, probably struct declaration. So normally you would think like maybe it's in here. This is the one where you start parsing the struct, but actually we do parse the anonymous structs and unions a little differently. This is actually different from how C sees it, because when C sees a union or a struct, that's more of a type declaration than C sees. So the anonymous thing is just like a type declaration that occurs. So will any value be accepted, or just in this parenthesis, or just enums, integers and enums, or anything that basically you could have, I guess, the const, but it will say that the 0 is the first element and so on. So, or it will basically match the value to the index. So So here we instead go into the struct body. Well, go get into that in detail later. So here we go into the struct body. We start parsing things, and if there is no name, then we're gonna add this anon here, which is a bit weird because can have several, but anyway, maybe it should have anon or name, or it should have the order of this member, but right now it's okay. So here we go. Here's a bit struct. It will be parsed a little differently, and here we have the union. So we're gonna add attributes, but the attributes are going to happen after. So we already parsed the name, and then maybe we'll parse the rest, and then we will. So if it token type, which happens to be we don't have that. So we have the decal kind instead. If the decal kind happens to be decal union, then we have the possibility that we want to parse this. So then we're gonna conditionally parse union. And what we need C, and we need a declaration that we're creating. Do we have that somewhere? Yeah, we have the number, so we're gonna have the number. And then we return the poison. Poison parent if it fails. But we don't have this one yet. Okay. So what about the case of just union? It has to be part of a struct with a field. And I did consider doing it differently. There are so many variants, but if you want to have this like really used for all the cases where you use it in C, you can't be picky. So you have to be able to say, okay, it's this variable which does decide it. It's still not covering all the cases of untagged unions in C, but almost. Like we're getting closer to it. So sema parse tagged union, right? Something like that. So we have the parse context, and we have the declaration. We can't write union because that union is the reserved name, of course. It will check against the field. At access, only in safe, it will only, check that it's true in safe mode. But what it will do is that when you set the variable, like change the value of that member, it will also update the tag. So basically what it does for you is making sure that the tag is in sync with the last field. So the last field you update, that's the one that the tag is going to point to. It's no more than that really, and the check. Okay, so we were here, right? Parse tagged union. Just call something else. I did write that. Parse tagged union and something up here. Parse, sema parse. What the heck? Okay, so now it might not be one. So what? Okay, yeah. So we are going to first try, if we can't consume a try consume. This means that try to use up that particular thing. We have the left parenthesis. So we assume that it's going to be like something like like that. So if there's no left parenthesis, then we're done. It's actually true. Otherwise, we already have consumed that one. So we want to try, so if toke as, so if token isn't C Well, very slow right now. Token ident. Ah, it's so slow. It's okay. It's with together with OBS. It kind of doesn't like me. Maybe I'll turn off a few others that are other things I have running. Maybe the computer will be a little more happy with me. So hang on, everyone. I'm just shutting some stuff down now. There we go. Another one, maybe. Here's another one. And oh, still sluggish. Still very sluggish. Oh, here we go. Have Xcode on. Like way in the back in the day, this you could never do that. Like have all these apps because it would eat up all the memory. Now it still kind of eats up your memory, but you don't notice it as quickly. So okay, now much fewer things up and running. I think. Right. Let me turn up some other things. So here we have preview up and running. And here we go. Okay. Feels a little faster now. Okay, so if it's not an ident, then we're gonna write some error message. So you're gonna return print error at here. This should be like the current aspect. And I did okay. The name of member closing struct that should serve as the tag for the unit. Okay, but now we have okay, so that means that was an error, right? We're gonna return an error, but now we have one. So we have this thing here, which is the tag name. And we're going to get that one from Simster. Going to take that from the parse context. Okay, and then we should be then continue and try to consume. And now we must have consume or read. So now we should always have. Let's see here. So get false, right? If we don't have the thing we want, namely a token rpar. Right. So now we're done. Now it parses, and now comes the difficult part. But we should notice we should see this parsing now. I need to have a main here because otherwise it will complain. Main. No Dracula for you. Okay. Let's close these down. Oops. Expected race. Okay. That's strange, right? Why didn't we get there? We are here, right? Parse tag. So we do have enter this and want to parse the tagged union. And it's pointing to this one as the one that's unexpected. Expected. So let's see what. Now something is wrong. So let's see. Always very useful is to set this. If you ever do want to debug, say through library and set breakpoints, always turn off the standard library. But if since we don't have the standard library, unfortunately, we need to have more easy. one of those. So let's see, we should have gotten into this part, I think. So let's see why we don't get there. So we have just have one member really, that is struct. So we get there, yeah, everything's fine, right? And then we go into this place and oh, if we don't consume, yeah, obviously. Okay, so now it should compile. And, all right, I think I lost my the pop out because I turned off Safari, which of course was having the chat. So give me a second and I'll pop out, give that pop out. There we go. Okay, now I think I'm back and seeing the chat window again, even though it's got really large. Anyway, so okay, we are, did we parse that? No, we're not done, right? Okay, we're still at the step 1. So we got the invalid token. Expected invalid token. Yeah, thank you for what? Oh, we didn't consume it. Yeah. So we have to advance one step, right? Advance because we are still at that tag. You have to advance one step. Okay, I think I put this wrong, right? So consumer red. The first one is the token. That's why. I have the other order for the returns, so it's a little confusing. It says consume, so consume the first one, yeah, and red the second. Yeah, that's correct. But yeah, that's no compile. Sorry about that. Like it's a glitch. Now, a problematic part now is like, where do we put this tag name? We want the story for analysis, of course, and we have now here we have data, and this is very highly packed. So we do have this thing, which is something shared. So here is the data structure that is the one that is special in the declaration. We have some struct. So we have a member, the list of members, we have the parents, and we have this union, right? So here's the one that is like, we have all the members and then we have stored somewhere. So we have padded decal union representation. The padding is packed. The question is, can we afford having a name here? Can we afford to have the const? Like, can we afford adding what the timestamp is? It's a 32-bit. So can I afford this? Const char name, right? Tag name. I'm going to show you tricks if we can't, but for now, can I do that? No. Oh no, not because of that. Okay, so that. There should be a static. Oh, it doesn't seem to be bigger anyway. So let's see. For declaration size is 136, right? And if I remove this one, it's so big. It's so annoying. Because that means like every variable will have this. This is something like, here's why you would want to have an an entity system actually on this one. Oh, the same size. So we are fine with actually having the tagging here, even though there's a way to compress it further. Okay, so we are here, right? We have the we can now store it. So decal struct tag name is this. So problem solved. Now we actually got to this part. So we are now into semantic analysis. So now we need to jump to our semantic analysis of the body. So analyze body somewhere. Let's see here. We can just probably look at struct. Analyze struct member. That seems very, very reasonable. So the struct members may be one of those, right? So we have attributes and so on, and then we're going to resolve a symbol and so on, and then we go into here and we just follow through, and then we analyze this declaration. Now, did we set the parent here? Because in some cases we want to know the parent of this one. Because it's only by knowing that we can do lookup into the parent's members to see this. So looking here, analyze decal. I wonder here if we are in this place, if we have that set. We might be. Okay, we didn't decal. Yeah, it's not C3, so we do that like that. Doom by doom. Right, so if we look at this declaration now, the question is whether it knows about its parent or not. So we go in somewhere here. And as you see, there are a bunch of different declarations, and here are the ones that are shared. So we have the parent already. So this allows us to kind of walk up actually the parent and the parent's parent and so on to look for this tag. So let's do that. So we say analyze decal, right? And then we're going to jump to the declaration, namely the union, where I just passed the struct union, right? And we are resolving implemented interfaces, all of that, and then we're going to store analyze union members. But before we do this, if is union and decal struct tag name, then we should find the tag. So we're going to do a if not sigma find tag union tag, right? And then we just pass in the context and the declaration. So because, well, so then we return false if that fails. So we can actually do something like this instead. Right, and then return false. So that's some comment here. locate union. So find tagged union tag. Put that over here. Static inline. Oh, context. Decal. Decal, right? And the question is whether it might be more efficient to do it past the, well, let's assume it's not going to happen all that often. Okay, so we now want to have that name equals decal kind decal no struct tag name. We can assert here. We don't have to have it. We can just assert that we have the tag, because otherwise we shouldn't enter this function in the first place. What next? Now we're going to look at the parent, which is decal struct parent, and I'll do a decal pointer. Again, we must in this case have one. Otherwise things are bad. We can have this. What? Too many arguments. Okay, and of course. Oh, it just takes the note. Okay, so okay, we have the parent, and now we can look for the members in that parent. We could also defer this, actually. We could also defer this lookup until we have looked through the parent, but we can also do it early. So maybe when I look at this, maybe it's better to just register this one as something they should look at afterwards. So the reason for this is that if you have something like what happens if you do this, if something, right? Sorry, I have some kids that I need to tell to be silent. On, folks. So okay, so I find the same ones, and just gonna have to, yeah. So yeah, so that's okay. So we're back here, right? What do we do here? We might match, like you could have. Imagine you have these, right? Actually, this, and now you're trying to match that tagged union, and you don't know which one you should match, right? Because only one of them will exist. So that's why we would like to defer this, actually, when I'm thinking about it. So let's defer this thing. So we don't need to do this thing now. But instead, that will mean that we do another pass though. So we also don't want to do another pass with if we don't know that we have unions, tagged unions in it. So what should we do about that? I'm trying to think about what's the cheapest way of doing it. Like for now, we can just remove this and the other thing that we added. Where is that? Right. So in this, where we do this, right? So we actually already know when we parse that we have a tag unit, right? So that's actually something we need to store the tag, right? Obviously, but do we need to do anything else? We actually just need to add it to a kind of a list that we need to know that, okay, I have children, so I need to do another pass where I look for the tagged units. And then I only do this pass if I have a tagged unit. So otherwise it will like cost for everything you do. It was like this constant cost, and we try to avoid that. We try to make the compiler fast. So there should be like a warning sign if you try to traverse something more than once, right? So what we can do here is that we're going to say, as we parse this and kind of find the tag here, then we can tell the parent that it has a member which has a tag. So if it is, right, we found the tagged union. So if we do have that in the member, so member struct tag name, right? If it has one, then we're going to tag this parent as parent, and it's going to be a struct, right? Because that's what it has to be, right? And it has some stuff, some booleans where we can put stuff. So we have the tag bool contains tag union, right? And that means we need to look for that one. And we can think about this like in two ways, but okay, let me show you another thing. So right, contains tag union. And this can't always be true, right? There's a reason why you didn't want to be. Okay, so let's say you have something like this. This shouldn't work, right? So we forgot, like, okay, if it has a tag name, then you just have to say, like, okay, the enclosed construct if parent declaration kind, if it's not a struct, then we should have return printer this member, say tagged union can only exist within, can only be defined inside of a struct. That's a normal, reasonable limitation, I think. Return printer isn't okay. The value. Okay, you have to return the value as well. So false. No, decal poison. Decal poison parent. Okay, at this point store. It's nice, not nice. It's nice. So you can have print error at. Return a decal poison. So now we can know that the parent is always a struct. And there's another thing here, right? So what we are excluding now from the design is the case where we kind of have, okay, we have this, right? So we have a struct, and then we could imagine having a struct here, bar, and that one has a union. And I'm thinking that maybe we should deliberately avoid this. So, I mean, there is, you could think about like maybe we should allow, for example, we could imagine this, like we have a bit struct here, and inside of that one we define int a, but it's small, right? Because we don't have the members. So let's place that one at this, and then we have a union a, and then we have like a union b, which has, you know, some other stuff here, and then you could put the other one in there. Right? So I think there's definitely an argument for this. There's definitely an argument, but everything will be simpler if we always assume it to be like something like this, that you do it, you know, put a char or something like maybe down here or something, that you don't have that bit packing. And the painful thing is that I do use that bit packing in C3. So C3 is very, the C3 AST nodes and so on, they are packed very, very tightly. So the tagged unions are definitely using more efficient things. So the question is, can it be, can this tag be found in a child of the struct? So that's the question. It shouldn't be in a union, because then we're like getting very, very strange, you know. Let's say we have int a and, you know, double v, and then we're gonna get very, very strange behavior if like setting, oh, we have a c here, c, right? Because setting this b will automatically set this one a, and that's kind of side effect if you have a union here is very, very strange. But a bit struct could be useful, like having it in a bit struct or an anonymous struct or a name struct. So I don't rule out like having it here in some bar, but it is a bit strange. It is a bit strange. By bit struct, that makes sense, but not something else. So I don't know. Maybe we could just do it like this for now. Unfortunately, this kind of locks in the semantics, but yeah, let's do it for now. So we gonna say that, okay, it contains a tagged union, right? It could be more than one tagged union. That's completely fine. But it's a tag. Okay. So that means that once we parse this body, actually, we don't even need that one. You see that? We don't need it. We could have a list here. And notice that we do have a limited number of elements in in a struct as well. But maybe it's just enough to do this, right? We can just do bool int that's union tag union or tag union members, and then just set that to 0. And then say, okay, a struct cannot have more than 32 tagged unions. Am I mean now? Max alignment. This is how it makes things fast. So define max tagged unions. It's going to say that that is 32. Max tag units. Okay. Tagged unions. Do give me your reaction to this. Yeah, max 8 would be plenty, but we have the space to spare. So, but you know what would you do if you had C++? You would of course create a list, a dynamic list here, because you wanted to be able to support any number of tag unions. So tagged unions, and then we take the member, right? Or we could just have the index of it. It's better to have the index, whatever the index was. There we go. There's an index there. Oh, the index is only added if it's what's the maximum members? You get quite a few members there. But let's see here. Okay, so first member index. I think we're doing a lot of funky stuff in there. Here's where we go through it and kind of. Okay, no, that's the regular members. That's non. So this is the parsing. I forgot that we're still in the parsing, right? So we don't need to do this, right? So okay, yeah, we don't need to do this. I'm doing this in the wrong place, right? We don't need to have that check, I think. So now, because now this is now inside of, like, we don't need to do that. We can take that. We can make that never later. So instead, as I was just putting too much stuff in the parsing. That's necessary. So let's go into the struct union where we were. So we are analyzing not the union members, we are in the struct members, right? So if we go in the union members, we're gonna like analyze it and stuff like that, and then we're gonna see somewhere here that it has, you know, if it's a struct member and it's not in. Okay, we can do like this: if member no. So if a member is, no, we're going to erase it. I don't want to erase it. I want to do it before we erase it. Or maybe I should. So let's look at this and say like, okay, let's tag. It's gonna be false, and we have like if has tag, it's going to be member decal struct tag name equals null. If parent kind is not struct. Then we're going to have like this return sigma error on the declaration tagged unions must be placed inside of struct. May only place that. So like that. And now we have this has tag, right? Do we do anything with that? Yes, we're going to tell the context that we do have that. So or wait, I can do that. Unnecessary. Okay, let me grab this one. So we have two cases, right? We have a member, it's there, and if decal struct, okay, if member kind equals decal union and decal member, like you want to keep as few of these lookups as possible. Like every time I see someone feeling like, oh, now I'm touching memory again. And yeah. That's what you have to do. Okay, so tag unit may only place inside of a struct, right? And in the other case, we are fine with that. So what we're going to do in the other case with the struct members is inside of struct. And now we're not going to do anything originally, and we erase it if we need to. And then we have the type, it could be a struct or something, but actually we don't care about that. We want to keep in mind if it's a tagged union. So we're going to have this list here, right? So signed, let's do int tagged. 0, and we have this list of tagged found and max tagged unions. So if we found it's erased, it's not erased. So if member, yeah, exactly. Oh, right. We're gonna contract that. So we're gonna set the index, I guess. So if the member is union and member struct tag name, then we're going to look at how many of those we have. If tagged unions found unions is equals to max tagged unions tagged unions, then we're going to have this error message return sigma error at this member, too many tagged struct may only contain tagged unions. This one would exceed. And then we take that. Oh, we don't need to do that. But okay, yeah, okay, let's go for that. So select units. Okay, so then we'll go for again definition there. Index unsigned. Yes. So tagged unions found. Maybe that's so bad. Tagged unions found. That sounds like count. Better. Tagged unions count. Tagged unions. That would be the index. Right. Of course. Right. Did I do something wrong? No. Let's see that it compiles. Does it count nested tagged unions or just the types? It's just gonna. No, it's not gonna count the nested ones. It's just gonna look at the direct tagged unions. Since we're not going to go up and down too much now, it's not gonna like. It doesn't matter. There's a nested one because the nested one cannot go past the it cannot search upwards, so you can't nest it 2 steps for now. Maybe you can. I mean, I'm not going to rule that out because theoretically you could have a struct in a well. Like you can make more complicated things. Theoretically, like I said, you could imagine having this in a struct because you wanted to have like all the data. Do you want to keep all the structs on the top, right? So definitely that could be something you ought to support later on. So, but for now, let's not do that. Right? We just want to do a simple version of it for now. I've learned to not, because it will be also it will be a little too complicated if you can look at it immediately. So now we're going to go, if we have these member tagged unions, unit count. Now we're going to look for the tags. So we're going to have like 4 like 0. I could just do this without it. Oh well. So okay. So we're going to have the index. Right. Index is tagged unions I, and that means that member is going to be what is it now? Struct members. Struct members index. Right, and then we're going to go through all the indices without except this one. So we're going to go for, we have the member count somewhere, right? Yes, we got for unsigned, unsigned even, j equals 0, j is less than member count, and if j equals I, then we just continue, and then we look at those members. So right now we're not going down into them, right? So we're just going to look at those members. So if member, let's have this const name member structs, we can't struct tag name. Okay. So if this particular thing that I'm looking at, which would be like struct member j name equals this tag name. In that case, we found it. So we can go to next after we do it. So let me just do like this. If it's not equals, then we just continue again. We can probably do like this. So we continue this list. Otherwise, we're going to say, okay, we found it. So it's it is at index. Oh, we're going to look at the name and make sure that it's an integer. Okay, so we have found it now. We are probably going to candidate is this struct number. Right, and we should have already resolved this one, so we know the type. So we can assert that candidate. Okay, and if it's not okay, so we can continue, or I guess it could be like it's not okay, but okay, well, let's assume it resolved. Resolve equals resolve done. That should be true. Okay, so now we're going to look at the type. So type is integer, type flat. Flat, and let's see what that will give you. So flat. Okay, flat distinct in line. That's the one I want. So I just want to flatten the type def and const of hang on. I want to flatten not just them, I want to flatten the enums as well. So flatten, let's see. Flatten to int, yeah. But I don't want to grab the, I don't want the butt-bit struct. I just want the const def and stuff. So this flatten gives me type def optional alias. Okay, type flatten inline. That's not the one I want. Type flatten. I should rename those to a better. This is not that good. Flat distinct inline. Okay, this is doing other stuff. So actually, I wanted, like, if you first, I can do like this. Okay. I will do this one, because this one will remove just the type defs and the const def. So type. And we take that candidate. And someone should do the canonical. Yeah, so now we have if type kind equals type enum or t equals equals loop. Type is integer. And then we're fine. So if it's not a type and the type is not integer, then we have return CMA error candidate the tag type was not an integer or enum. Or something like this. Please use integer or enum as the tag. It's not valid. And I would take type code error string, yes, and take that type. No. So the original type of that thing, right? So now we know that the member is something that can reasonably turn into that. Now, there's one thing though, like if it is an enum, we want to make sure that the enum has enough values to cover, like it should be the same as the number of members in that union, right? Otherwise things are weird. So if t type kind equals type enum, then we're going to look at that particular candidate. That enum. So then we have decal is going to be t decal enums. There we go. I'm going to have that one, and actually we can just do like this. So then we say if enum vals is not the same as this number and its members. Size. Then we take return same error here. Error, and we have the candidate. This tag as an enum. That's the type, which has values, but the enum has different numbers values, so they do not. So let's down, and we need to have the type code string t, and should just take the candidate time. This one there. And the enum has, this one has, okay, enum vals. And then we have this one, which I don't need to, otherwise I don't need to store that. Yes. Maybe I should. Back to the union. Union member count. Okay, so then they differ, right? And in the other case, it's then a value, so we only have a special case. So if the union member count is greater than, you know, the type, like what's the size of that type? So type type size of T. We basically only need to worry about signed, unsigned. Okay. Okay. Do we have that? Where type max value? In the range or something. So we have, if it's integer signed, right? So we know this. Okay. So if type is integer signed, then we have like, okay, if it's if union member count is greater than, we can switch out the type size, switch size of type, case. So we get something like this one as well. So it's just 8, right? Then we get like if it's signed, is signed, or and what's that? The union member count is greater than 1.7. Then we have like, or we can maybe we can max. Okay, I don't know. Like let's set max. Right, so max is 0, and then we have like max equals assigned. 7, 5, 16, max. I'm having a break. We only need this one, right? What's that? Let's make it takes, so I don't need to think. And is it 0 FF? And then we have 7 FF. Right. FF. Break. And after that, we're not going to check it. So like that. I'm just gonna set it start. It starts at, you know, union member count. Anyway, so if union member count is greater than max, then we count this. Tags are type wow, which present blah 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 values, but the union has larger height, something like that. And then we have the max. So now we're kind of fine and we found everything we wanted and so on. Why is this switch? Didn't I have a break default? Max, okay, yeah. Okay. It's already checked that it's this one, this cost is fine. And then we go to next, right? So we go to next after this check here. And if we fail, then we have just gone through these and haven't found any. We're gonna have an error. So turn sim error for the member itself. This untagged v untagged unit. Why did the right untagged somewhere? So the tagged union had its tag is good. This. Good. What's the name there? So we have tag name, right? So tag name. Okay. Go to next. So let's just run with this. Should probably break, right? Somewhere. Well, let's give ourselves some test cases. Tagged unions could not be found in the parent struct. Yeah, that's true. So that's one. And we could have another one. It's foo2. That should work. We just do it like this, right? So foo2 should, it could not be found. Look, okay, it should work and it doesn't. So let's see why it doesn't. So we're going to jump into this one and start looking at when it starts searching. So first of all, we have the one that fails. That one, we don't need to check that one. But the second time, now we actually have something. So we're in this thing here. We're going to look at the first candidate, which is okay. So tag name, the member. Let's remove the first one that didn't work, that we know doesn't work. We can move that to a test case maybe later. Well, we can do it like this first. Any questions so far? You know, let me know. Oh, I realized I never did I didn't say. And let me get back to this. Okay, so we're here, right? We have our tagged unions is this. Oh, so it's not about now. It should be this index, right? Otherwise, we're skipping the wrong one. So that one worked, right? The second one worked. The first one shouldn't. Yeah, so we have those two, they're working. Now I'm going to add another one. That shouldn't work. So we're going to have in this case, we're going to have foo3, we're going to have an enum. APC, but it's just going to have one element. Or you can have three, right? One foo bar baz. And now it's going to say like it's not the same. So it's going to have ABC, which is going to be fine, right? But it's not going to work. So we're going to have, first we have this one that doesn't work. We can have one that works. See here, that one works, and we have 4, and that one doesn't work. This tag is which is an enum, but the union has 2 different values, so they do not match. I should point to that thing as well. So SEMA error, and then SEMA note to that member, the tagged union is here. Return false. Or maybe I should even like point some false, but no, it's just false. Okay. Right. So that's an error there, and then we're gonna get to the next one. So let's go for the integer one, which is gonna be horrible. Okay. How do I do that? Maybe it's gonna have like you have a struct foo5, which has like so many we have an char, no, ichar, it's the smallest one I can get. And then we have a union A, and then we have like, we have int A. Then we're just gonna, can we do this in a nice way? So it's gonna be like 1, 2, 3, 4, 5, 6, 7, maybe, yeah, 7, 8, 9, 0. Then I'm gonna have this one like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Not at all messy, right? I love it, like the indentation here. It's very advanced. Thank you for that. It makes me not want to test this. I should have used no indentation, but it could have worked better. could be worse. I guess. Can always be worse. Could have had to indent this without that column. It's like I could make a cogen doing this cogen, but I'm not eager enough. 1, 2. No. 1, 2. Yes. 3. 4. 5. Let's continue. Like I'm too lazy so that I have to work. This is not good. I'll go into some test case and then we'll never see it again. I hope. But this should be enough. Ah! Right. There we go. And now it should hopefully say that there are too many. No! What is this? The union doesn't cover it. Let's see. How many union members do you have? I thought it was over 107. Is it signed or not? Let's see here. Yes, it's signed. Good. And then we go for the max, and then we go to what? What's the type? It's I8. What is the type size? Should be 8. No, it's just 1, right? It's 1. It's not bit size. Bit size, not byte size. Right, now it should work. I hope. So you need a larger tag type, right? Okay. So far so good. We are parsing this. We can make some, you know, we can put those into test cases. So this was the one. Let's see here. So this was one that doesn't work. Union something. Union. There we go. Let's do tag union fail. 3. So we have this one, and it should be. Oh, this is so beautiful. Indentation. Can I get some? No, I can't get indentation. Probably because the union is violating the normal syntax, but still. I don't think there's a reason for it to randomly destroy the format. Okay, so we got that one, this one, this one, this one. This is our working one, right? And let's put these in here. This will fail. Oh, this one will succeed. Sorry. And this one will fail. Did it? All right, it should be better. Okay, I'll improve that one. So still it's going to be like here. And in this case, it will be an error here. And what else? So here you will get an error here. So what you want for this though is that aside from actually having the format work, like this random formatting is not my thing. Yes, it's a test case, but why? So in the last case there, we wanted to have more information about where it is. So blah, blah, blah. So we have the same error there. You need to probably type tag type union. Tag union is defined here. Right. So I think that's better. So let's see what that looks like. So you would would need a, yeah. What? Okay, I removed that, right? Let's keep it and see the error again. Now, okay, that's good enough, I guess. Let's run the tests and then fix up the error messages for now. So let's see there is anyone having a question. Okay, so what is C3? Yeah, C3 is a programming language. It's it's not strange that people don't know about programming languages. It's like if you are deep into writing programming languages, you have like this 360 view of like all the language, the C-like languages there are. Also, if you ever dive into it, you get quickly get a view of what's there and what isn't. But if you're just programming in general and you hardly know anything about other programming languages, then the odds that you know about C3 is very, very minimal. Like, I remember how long it took for Rust to even get, you know, some recognition. That actually took quite a while. So it was like for a long time, it's like, yeah, that language, that Mozilla is like this, the Mozilla language. Okay, here we go. So here's the, I'm just going to do like this. I just copy paste them into this code here. So this time, blah 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 blah. Asta, okay, not Asta. Thank you. This tag has. which can let's keep this like not to do it again. Right. So I'm just going to do my personal. I'm going to, okay, let me take a new branch and create dev here and overwrite the existing one. And then I'm just going to do like parsing tag union. So it's not doing anything else. I'm thinking that maybe this would be like a good place to stop. We've had 1 hour and a half. Anything else? Like anything you want to ask me about before kind of move on? So what we have now is, you know, let's review that. We have this one should work, right? So for example, so we got to part of the semantic analysis. It's not all of it, or actually maybe it is. It is the semantic analysis, but it's not storing what the actual member is. So we could do that. Let's keep that. So we have this after we're done, right? We have done all these things. We are fine with this. Then we can switch this. Since we are resolving things anyway, we can always say, okay, now we know the tag name. Now we don't need it anymore. We instead just want the index of this particular tag. So that's what we're going to store. We can actually store that immediately when we find it, even though it's not correct. So I can take the member, right? And because the tag name, we have the struct, then we have the tag name, and we can have like a tag name. Where is this? Now we're going to say like, okay, and then we have a union here. So like how I use these unions. Okay, so we have a union, and this is probably why I'm like not saying that this is like this even with this tag, it's not going to be the end of all things. So okay, so the tag one, and it's going to be like unsigned tag, basically. So we're going to see that the tag is equal to J. Now we know it's the parents member, right? The tricky part is like, how do you refer to a parent's child or something? That's one reason why we don't really want that, because then the codegen will be a little more gnarly, trying to look up where like relative to this thing, where should we do the modification. But still, we could do that. We could like store a relative, like byte relative offset to that member. So that's quite possible. So right now we're not doing it. We're not doing anything. We're just doing this silly thing.